Hi friends, welcome to follow up. In this video, we are going to look at problem 150, evaluate reverse polish notation. Here, our main purpose is to demonstrate the use of stack data structure. So actually, this is a very classic problem. So our plan will be the following. First, we're going to digest the problem requirement, and then we explain how to do the coding. Now let's look at the problem statement. So here we are given an array of strings called tokens that represents an arithmetic expression in a reverse polish notation. So we want to evaluate the expression. So we want to return an integer that represents the value of the expression. So here are some very useful notes. Here the operators are plus, minus, multiplication, and division, right? So notice that you need to pay attention to this division, because here we want to return an integer, right? So here the division between two integers always truncates towards 0, right? So each operand may be an integer or another expression, right? There will be no division by 0 phenomena in this test cases. And the input represents a valid arithmetic expression in a reverse polish notation. And the last one is basically the answer, and all the intermediate calculations can be represented in a 32-bit integer, right? So with that said, let's also look at the three examples. So the first one, actually, if you see, we have 1, 2. Here we have a plus, right? So we need to first get the result for this two. If we look at from left to right, so this is 3. Then we have another 3, and then we have a multiplication. So we have 3 times 3, that is 9. So now if you look at the second one, so if you look at scan from left to right, you see 4, you see 13, and you see 5. All these three are integers or strings or integers in string format. Then you look at division. So then the previous two tokens are the corresponding operand. Notice that the order is important, because we need to use 13 divided by 5, right? So this one gives us 2.6, but we need to use 2, right? So because this is towards 0, so we have 4 plus 2, right? So here plus is due to this one. So this three tokens give us 2. Then this has a 4, so 4 plus 2, that is 6. That's the second one. So similarly, you can interpret the last example. So here the constraints are the following. So the lengths are bounded above by 10 to the power 4. So this number 10 to the power 4 basically give us a upper bound on the problem size, right? So tokens, each token or tokens as the generic element I, tokens I, is either an operator, so plus, minus, multiplication, or division, or an integer that is in the range given in the closed interval, negative 100 and positive 200. So with that said, basically we are ready to look at the idea. So actually for this problem, basically once we use stack, we just need to do linear scan, right? When we do the linear scan, we look at the current, we use a stack to hold the elements, right? So I'm going to use the second example to give you a walkthrough. So then when you look at the first element, so which is a integer, so we're going to push this one to the top of the stack. And then we look at another one, it's still a integer, so we're going to put to the top. And then we look at another one, that is 5, so we put to the top of the stack. And next we're going to meet a division, right? So this division, then we are going to pop the last two elements. So after we pop the two elements, you get one is 13 and one is 5. But here we need to pay attention to this order, right? Then we get the result of 13 over 5. That is 2.6, but we need to get 2. Then we push this result to the stack. So this way we have stack equals 4 and 2. And then we continue scan the tokens. Then the last one is a plus. So we have a plus. Then we need to pop another 2 times. So we get 4 and 2, right? But addition is commutative, but still we need to pay attention because we a priori do not know the operator type. So that gives us 6. So this is our quick walkthrough for example 2. So with that said, I hope that you have grasped the idea. So next, let's look at coding. Actually, the coding is rather straightforward. So for convenience, I'm going to make some import. So from operator, so I'm going to import so addition and subtraction, multiplication, and true division, right? So with that said, this is just for convenience because I don't need to check later the corresponding function corresponding to the operator types. So I can make a dictionary, for example. So I can use plus corresponding to the add. So notice that this add, sub, multiplication, and true division are all callables, or you can just think of them as functions. And then you have minus, so you have sub, and you have multiplication. Then you are going to map it to this callable. And you have division, so you have true division. So this is some very straightforward preparation. So next, I'm going to initialize a stack, initially empty. And then I'm going to linear scan the tokens list. For token, in tokens, right? So first, if token not in D, it means that the token is integer in string format. Then I'm going to push that token to the top of the stack. So stack append. So I'm going to make it an integer, right? The token. So as we have this, so we'll continue to look at. So another case is that the token is an operator. So in other words, the previous 2 should be operands. Then we can do pop. So this, let's see, item 2, that will be stack pop. And item 1 will be stack pop. So here we are going to use item 1 to end the operation, because here the operations are all binary operations, right? So then the result will be, let's see, we can use a temp variable. Say the result will be the corresponding function, then apply to item 1, item 2. So here, this order of arguments passed to the callable gives us the order, right? Because it's important to know which one and first. For example, for subtraction and for for division, right? So then we are going to do stack append the temporary variable. So here we want to notice that we need to take integer, because this one might be neutral or just have no effect, but for division it will have some effects, that is truncates towards 0. So with that done, so after we finish the for loop, by the assumption of this problem, stack should contain only one single element. So that's the one we want to return. That's also the evaluation of the expression. So we're going to return stacks 0, right? So negative 1 is the same because it's one element. So with that done, I guess that's it for the solution, the coding part. We can do a test. Yeah, it passes. I guess this is example 3, right? So now let's do a check for generic case. Yeah, it passes all the cases. So yeah, last did is many years, a number of years ago. So here, it's, if you like, you can you don't need to introduce this temporary variable, right? You can directly append integer convention of this part, but this is just for a minor detail. So with that said, I guess that's about it for this video. In a follow-up, in a series follow-up video, I'm going to do some problems related to binary tree traversal as a review. You're welcome to follow up. So with that said, thank you for watching.